Hi, class. Since we didn't make it all the way through yesterday's notes, I wanted to do a quick video to finish that up with you. I will be going fast, so if you need to pause the video or re-listen to a part of it, please do take advantage of that being a video. You can do that. All right. So we're going to first, we had started talking about how do we name polyatomic ions. Remember, a polyatomic ion is something that has not only, it has more than one atom. It has more than one atom in it. Right? And we can see here, there's more than one element. There's more than one element in that, makes it a polyatomic ion. More than one element, polyatomic. Only one element, that is just a single element, right? It's not polyatomic, one atom. All right, when we're naming these, they start off the same way we did if it was just a binary. If it was a binary, I mean it was the single element, the positive ion, single element, the negative ion. Start off the same way. I want you to be careful, though, of NH4. Why? Because that is our only positive polyatomic ion. Why is that important? It's important when you look at the examples here I have in the bottom of the screen. If it does not start with NH4, there's only one atom in that positive ion. CaCO3 doesn't start with NH4. Ca is our positive ion. K2SO4 doesn't start with NH4. K is your positive ion. MgBr2 doesn't start with NH4. Mg is your positive ion. Na2 is your positive ion. Here it starts with NH4. That means NH4 is your positive ion. That's why it's important. That's why I want you to be careful at NH4. All right. So where are we at? Our cation goes first. Our cation, that's your positive ion. We're always going to write it down first. Just like we did with the binary ones. And then we're going to follow that up with our negative ion, or anion. Now I want you to pay attention to details here. What do I mean by that? What I mean is if you look at this NO3, NO2, and simply an N, they are a little bit similar, right? This one has 3 oxygens. This one only has 2 oxygens. This one doesn't have any oxygens. But the names for these are very, very similar. You need to be careful. Normally I don't care about spelling because I can figure out what you mean. Here I need you to be more careful with your spelling both ways, right? When you look at a word that you know which one I'm referring to, and the same thing if you give me a phrase. So nitrate, again, notice that. Look how similar these names are. A, replace it with an I, replace the T with a D. These are all very similar. So be really careful when you're looking up nitrate that you know you're talking about this guy. Or when you're writing the name for a nitrate, for an NO3, you know you're talking about that guy. So you can be careful with your words, with your spelling. Which one are you using? Okay. All right, so let's go through. Let's name these guys. We're going to name them very similar. Our cation goes first. What's our cation here? Our cation here for calcium. Right. We look up CO3. Right. We know what's left has to be our negative ion. So let's go through and box in the rest. Whatever the rest is our negative. Whatever the rest is our negative. Whatever the rest is our negative, our anions. So now that we know what each ion is, we just name our ions. Calcium's our first ion here. CO3, look it up on your polyatomic table. You see its name is carbonate. Same thing, we go over to the K2SO4. K we know is potassium. SO4, look it up on your common ion sheet. Oh, sorry. SO4, you look it up on your common sheet, you'll see it's sulfate. Let's go back here to the magnesium bromide I just put up. Mg, your first one, magnesium. Br, this is not polyatomic, just one element. So we need our IDE form. We change our bromine to bromide. Over to the K2SO4, right? K we know is potassium. SO4, look it up on your common ion. You see it's sulfate. Again, be careful. You should write the right word there. Your spelling's good. And below we have sodium. There's our first ion. CO3, look it up on your common ion table. You see that it is carbonate. The very bottom here we have NH4. That's our positive ion. Our negative ion is also polyatomic here. So we have 2 polyatomic ions. The NH4 we see from our common ion table is ammonium. OH we see is hydroxide. So naming them is pretty easy. You just got to know how to break your formula into the positive and negative parts. Pretty easy. It's only one. The positive part, your first one, is just that element, unless it starts with NH4, and then that's your positive ion. What if I give you a name and ask you to write me a formula, though? What are our rules here? Just like they were before. I want you to label the charge of the ion. Label the charge of each ion. Then remember, the charge must be equal to 0. When we sum up our positives or negatives, they must cancel each other out. You must have 3 positives or you have 3 negatives. Right? They got to cancel each other out. That sum must be 0. We have a third rule here that's new for polyatomic ions. I'll talk about this in a moment. So let's look at how do we name them? How do we come up with their formula? Sodium, we look on the periodic table, because we know sodium is an element by now. Positive 1, you might even be able to recognize this because we use sodium a lot. Bicarbonate. If you can't tell if something is an element or a polyatomic ion, see if you can find bicarbonate. Look on your common ion table. If you can find it in your common ion table, then you know it's a polyatomic ion. If you can't, then you know it's an element. Find it on the periodic table. We find bicarbonate, and we're going to see that its charge is -1. So how do we write this formula? We just got to write the formula for each of these ions. Formula for sodium is Na. Formula for bicarbonate, again, you look on your common ion sheet, and you see it's HCO3. So we're going to put an Na for the sodium. We're going to put an HCO3 for our bicarbonate. Let's look at the next one. Potassium, element, group 1, positive 1. Chloride, IDE, that should be screaming at you that that's an element. That's the IDE form of chlorine. Find chlorine, it's in group 7. That means it has a -1 charge. Do our charges balance? Yes, 1 positive, 1 negative. We just got to write down then what we see. Symbol for potassium, K. Symbol for chlorine, Cl. Let's look at these next few. We're getting a little bit more complex now. Now we have sodium, positive 1, that we've already seen that. Sulfate, it's not an IDE, so we know we're talking a polyatomic ion. Look it up on your polyatomic ion sheet, and you're going to see that its charge is -2. So our charges don't balance here. 1 positive, 2 negatives. We need another sodium here. So when we write our formula, we're going to put down a symbol for sodium, our Na, but we need 2 of them. So we're going to write Na2. Then we look up on our common ion sheet what sulfate is, and we see that formula for sulfate is SO4. So very similar to what we were doing the last few days. We put down our first ion. How many of them do we have? We put down our second ion. How many of them do we have? If we only have 1, then we don't have to do anything special. We're done. So we calcium hydroxide, our next one. 2 for the calcium. Now hydroxide, even though this ends in an IDE, unfortunately our names can be a little confusing, you won't find an element called hydroxide. So look it up on your common ion sheet. You're going to find that. You'll see that its charge is -1. Our charges don't balance here. We need another negative. Now we have 2 positives, 2 negatives. We're good. How do we write that? We're going to write the symbol for the first ion, Ca for the calcium. We only need 1, so that's all we're going to do when we're done. We're going to write down the symbol for the next ion. We see from our common ion sheet, rather. The symbol for hydroxide is OH. We need 2 of these. How do we show 2? That's where this rule here comes in. If you need 2 or more of a polyatomic, I need you to put parentheses. Use parentheses around the whole polyatomic ion, and only the polyatomic ion. So here we have 2, we need 2 hydroxides, so we got to put parentheses around the whole polyatomic ion, that OH. Then we need to put the number of them on the outside, 2. So just like we put the 2 here for the sodium to show that we needed 2 sodiums, we put a 2 outside here to say we need 2 OHs. Now just a word of caution as we're doing this. I want you to think about this for a moment. Here we've written down our calcium. We wrote down our first ion. We've written down OH, written down the second ion. But if you recognize you need 2, what happens? What does it mean if you put a 2 there? Well, that'd be very misleading because that looks like you need 1 calcium, 1 oxygen, and 2 hydrogens. That's definitely not the case here. So please don't do that. A very common mistake I see students do. Very common mistake. Another common mistake. Well, you need 2 oxygens, you need 2 hydrogens. Yeah, you got a hydroxide, you need 2. Well, what does this tell you? Make that a little bit neater. What does this tell you? Well, that looks like, it's right, you got 2 oxygens, 2 hydrogens, but you've lost some information when you do it this way. You've lost the idea that this OH is really a unit. Right? These guys stick together. Don't separate them. There's a big difference between this. That is not the same as this. Right? Here it doesn't say anything that there's a relationship between that oxygen and the hydrogen. Here it's very clear that that oxygen and hydrogen are bound together to be a hydroxide. So be really, really careful. If you need 2, write down the ions formula, OH for your hydroxide. How many of them do you need? If it's polyatomic, put your parentheses, and then put the number you need outside. Very, very important distinction. Be careful with your parentheses. Notice we only need them when we need more than 1. Here we had an SO4. We only needed 1 SO4. We did not need parentheses here. Finally, our last one here, ammonium carbonate. We look at our common ion sheet. We see ammonium carbonate's a +1. Carbonate, common ion sheet shows that that's a -2. So we need another ammonium. So we'll start this off in a similar way. We're going to write down our common ion, our ammonium, NH4. Write down that ion. NH4 is our ion. How many of them do we need? We need 2. We need 2 ammoniums. So we're going to put parentheses around the ammonium, the NH4, and then we put the 2 outside of it. Carbonate, we see that its formula is CO3. We only need 1 of those guys, so we're done. We don't need parentheses. So be very careful with your parentheses. Use them when you have 2 or more of a polyatomic. Use it when you have 2 or more of a polyatomic, like we did here. Let's change my tool. Use it when you have 2 or more of a polyatomic, like we did here, and like we did here. Okay? If you don't need 2 or more, don't use parentheses. If you don't need 2 or more, don't use parentheses. We only needed 1 here, no parentheses. We only needed 1 here, no parentheses. We only needed 1 here, no parentheses. All right, so that's done with our notes. Let's move on to the worksheet 2, which is in yesterday's folder. Let's think about this first problem real quick. Why is the formula of calcium nitrate? Why is that CaNO3 in parentheses in a 2? Why is that CaNO3 parentheses in a 2? Why isn't it just CaNO3? Well, let's look at the charge here. Calcium, group 2, it's got a charge of +2. Nitrate, we know that that is, again, polyatomic because it does not end in IDE. Nitrate, we looked that up on our common ion table. We see it's got a charge of -1. If we just wrote down the symbol for calcium and we just wrote down the symbol for nitrate, we don't have balanced charges. There's 2 positives here and 1 negative. That doesn't make that. We need to balance it. What do? We need to have another negative. We need another nitrate. So how do we write that in our formula? We got to be clear that it's a nitrate we're talking about. So we write down our ion. We need more than 2, or more than 1 rather. That's when you need your parentheses around your polyatomic ion, and then you put the number you need outside, 2. Let's go on to the next part of our worksheet. I need you guys to be doing questions like this for the quiz tomorrow. First thing I want you to do as you go through here, again, just like we've been doing, you see the atom, write down its stable charge, lithium group 1, +1. NO3, more than one element, it's polyatomic. Look on your polyatomic sheet. You see its charge is -1. How do we do our visual representation? Remember, when your visual representation, I want you to start off, write each ion. Write each ion. Do we have balanced charges? We have one positive, one negative. Yes, our charges are balanced. We're done with our visual representation. Now we just have to write down what we see. We see a lithium, so we're going to start off with the lithium. We don't need to put a number next to it because there's only one. We see our next ion is NO3, so we write down NO3. We only need one of them. We're done. How do we name it? Li, you see in the periodic table, is lithium. Your common ion sheet will tell you that NO3 is nitrate. Let's look at the next one. Boron, group 3, +3. OH, more than one element, it's polyatomic. Look OH on your common ion sheet, you're going to see that its charge is -1. So on to our visual representation, we're going to put down our boron, +3. We're going to put down our hydroxide, our OH. But we can see here that our charges aren't balanced. It doesn't sum to 0. We need more negatives. So let's put in another negative. Now we got 2 negatives. We need one more, so let's put in another. 3 negatives, 3 positives. We're done with our visual representation. It balances to 0. How do we write our formula? It's similar to what we did up on the first one. We start off with a B, because we got a boron. How many do we have? We have just one. Our second ion is an OH. How many do we have? We have 3. We have 3 OHs here, so we got to put a parenthesis around that. This is a polyatomic ion. Let's symbolize what the put parentheses around the ion, and then we put a 3 on the outside. Okay. More than one of our polyatomics, so we have to put parentheses around the whole polyatomic ion. And finally, the chemical name, what do we see? B is boron, OH, our common ion sheet tells us is hydroxide. Try it. If this makes sense to you, try the next one on your own. Check it against the answer key. If it makes sense, awesome, you're done. If it doesn't make sense, practice, do another one, see what you can learn from your answer key, try the next one, do a couple more practices till you have it. If it still is confusing, send me an email. 2 more pieces on our worksheet to go through. First, I want to talk about if I give you a formula and I ask you to give me the name, this is pretty easy. You don't need to worry about charges when we go this way. All you got to do is write down what you see. We see an H and a Br. It doesn't start with NH4 rather, so we know that that's our positive ion. What's left is our negative. All right, let's just do that really quick for the rest of them. Doesn't start with NH4. It means we only have the one atom in our ion. Rest is your -1. Ooh, does start with NH4. So that's our positive ion. The rest is your negative. Doesn't start with NH4. SR is our positive ion. Rest is your negative. Does not start with NH4. Ba is your positive ion. Rest is your negative. And we can keep going through. And the key thing is check and see if it starts with NH4. Should be your first question. If it starts with NH4, that's your positive ion. The rest of it, again, is your negative ion. All right, so how do we name them? We're going to just name our ions. We start out, we see here with the HBr at the top. What's H? What do we call H? H is hydrogen. Br, bromine, but we got to change it to the IDE, hydrogen bromide. Hydrogen bromide. Let's look at the next one. Al, we know it's aluminum. NO2, we look up on our common ion sheet. NO2, we see that it's nitrite. Again, be careful with your spelling. Make sure you use the right one. Don't write down nitride. That would mean N, not NO2. Don't write down nitrate. That would tell me that you were looking at an NO3. Let's look at the next one. I think, yep. Let's look at the next one. NH4, we know it's polyatomic. Look it up on your polyatomic sheet. ammonium. PO4, again, we looked that up on our polyatomic sheet, and we see that its name is phosphate. Again, break them up into positives and negatives. If it doesn't start with an H4, it's just the one element. If it does start with an H4, that's your positive ion. The rest of your formula refers to your negative ion. Again, try a couple more of these. Check your answers against the answer key. If you're doing well, great, you're done. You don't have to do them all. But make sure that they make sense to you. Scan them real quick. If it still doesn't make sense after this practice, please send me an email. Last part of our worksheet here, this is where it's important that we have to write down our charge. It's very important that you write down the charges. You got to check the charge to make sure it's neutral. Check the charge to make sure it's neutral. So again, what are we going to do? We look at our calcium, find it on, we know that that's an element, +2 for its charge. Sulfate, again, doesn't end in IDE, so let's go ahead and check our common ion sheet. We're going to see SO4, some sulfate rather, has a -2. Do our charges balance? 2 positives, 2 negatives? Yes. So we just write down each ion. Calcium is Ca. SO4 we see from our common ion sheet is, sulfate we see from our common ion sheet is SO4. So we got our next one. Boron, group 3, +3. Sulfide, here's an IDE. I do want you to be careful. We do have a few polyatomic ions that end in IDE, but we never have a monoatomic ion, which is one element, that does not end in IDE. Sulfide, we look at our periodic table. Sulfur is group 6. We know that it's got a charge of -2. Do our charges balance? Nope. We need to add more borons in sulfides. Now we have 6 positives, 6 negatives. We're balanced. Write down our first ion, that's B for boron. How many do we have? 2. Second ion, sulfur. How do we have? 3. Let's do one more. Sodium. Periodic table tells you group 1, +1 then. Sulfite, common ion, right? Does not end in IDE. Find that on your common ion table. We're going to see that it's -2. -2. We need more sodiums. Now we're balanced, 2 positives, 2 negatives. How do we write this? We're going to start off with the first ion, sodium. We write the Na. How many do we need? 2. Then we're going to write our second ion, sulfite, SO3. Sorry, I got a typo there. Sulfite is an SO3. We only need 1, so we're done. We don't need any parentheses. So look at ammonium phosphide. Ammonium. That is our only positive polyatomic ion. We can see that our sheet tells us that that's 1. Remember, our positive ions are on the left, negative ions are on the right on our common ion sheet. Phosphide, that's an IDE. That's an IDE form of phosphorus. Phosphorus group 5, that means it's got a -3 charge. Our charges don't balance. We need more positives. Here we go. Now our charges are balanced. 3 positives, 3 negatives. So we know we need 3 ammoniums. So first off, what I want you to do, you're going to write down the ion. NH4. We need 3 of those. So we have to put parentheses around that ion and then symbolize that we need 3. Phosphide is phosphorus. Symbol's P. How many do we need? Just 1. So again, I want you to be careful. Where do you need parentheses? Where do you need parentheses? I mean parentheses again. Only need parentheses when you have more than 1. Right? Only need parentheses when you have more than 1. Now be careful that inside your common ion here, the NH4, don't drop that 4. That's part of your ion. Make sure you keep the 4 as part of your ion. That was all I wanted to show you guys real quick today. If you have any questions on any of this stuff, please send me an email rather. And today's folder I also give you the list of things that you need to know for tomorrow. All right, guys, good luck. Talk to you tomorrow.